There we go.
What's insoluble?
Insoluble.
Oh.
I don't even know where the word is. Question? Electrolyte conducts electricity. We've kind of already done these. We've done different versions. Non-electrolyte does not conduct electricity. The reason they advertise electrolytes and things like Gatorade and Powerade is because when you do anything physically exertive, such as sport, you sweat a ton of salt out. Again, your sweat is basically dilute urine. It actually has quite a high salt concentration. And if you get enough of it out of you, that can be extremely damaging to your health. But even a little bit will stop you from performing well. So they say it's an electrolyte, which is true. Then they stuff it full of sugar, which you don't necessarily need. The best thing probably after, you can ask Mrs. Nurse Decker if you'd like, is apparently a banana and chocolate milk. But a banana and water will work. You'll get hydrated. The milk, if you have it, will give you back some protein and fats. And the banana contains a lot of the electrolytes that you need, and it does have some sugar with a little bit of fiber. If you're slamming Powerades or energy drinks, you might get some electrolytes if they include it. But you get way too much sugar and probably way too much caffeine.
Don't you want to eat salt?
Don't you want to eat salt?
Yeah, like after a workout. Like
Yeah. So that's what the electrolytes are providing. We often don't need to eat a lot because the North American diet tends to include a lot of salt to the point where it actually has too much. But if you're in ODP or any sort of physically exertive thing where you leave civilization, many of those people will take salt pills with them because you can't actually add enough salt into their diet in order to do it, and you need it, otherwise you will go into a coma and die. Ettusions. I have no idea what that means. But I can answer, what type of reaction is this? Yeah, it's like right there. This is dissociation, so it has ions that separate. HCl ionizes because it becomes an ion. So there's the two different types. HCl is a strong electrolyte. The light will be bright when I actually show it to you. You get 100% ionization. Every possible ion you could get, you will get. I use citric acid in the demo because it's a very weak acid and it's very good for that. For writing the formula, I'm using acetic acid as an example here. Vinegar is also a weak acid. So 0.1 molar would also give very little light. It doesn't ionize really well because there's not many ions. Most of it is just sitting around like this. It dissolves like this and has an equilibrium in water where you have the acid form dissolved with a little bit of the base form and a little bit of the H+. Oh, it's starting again. Good? Any more needed? Yes, no? Oh, no, not allowed to see that one. I'm going to ask you a question. Strong acids and strong bases. I would like you to write all the strong acids here, all the strong bases here, at least 4 examples of a weak acid and 4 examples of a weak base. I'm going to go around the classroom 2 or 3 times, asking you for one of them on there. So if you have a few examples, you'll be able to quickly pull one up when I do so. Just make sure you can classify them. So where is that? There.
Strong bases.
For the strong bases, have like, I don't know, 5 examples.
What?
What?
Strong base.
What do you get those? I don't think this was
Yeah, that's a base.
these, but there's only two. Oh my god.
Well, H2O. Yeah.
Mm-hmm.
Did you ever get that lab back?
Yeah, it's like you've seen your lab score get updated on your rating thing. I didn't write anything in your lab book, but I did make an entire page of feedback. Now that you mention it, you don't have. I am going to use it though to write your report. I should probably hand that back.
Here.
It's fine. I'm already in.
Okay, we good to go around?
No.
Where's the
Did you get it?
where's the
For
thing?
what?
Engineering and math.
Just general you? Wait, is it general?
It's general first year. You applied to UBC?
No. I had to down Miguel. You got
McGill's so good. It's like so hard to get experience. That's what you have now, right?
I put like a 94. Which one?
That's for what type of engine? Bro, McGill's just like hooked to like just for mechanical engineering, I think like their average
Mechanical
acceptance
so
is like it's like 97%.
Yeah.
Okay,
It's possible.
we'll start with the person talking about Miguel. Give me a strong acid.
Hydrochloric acid.
Oh, it's way too easy. Okay, strong base.
Hydroxide ion.
No,
Oh.
that's an ion. I want an actual base.
Ammonia?
No, that's a weak base.
Large HPO4.
HPO4 is a weak base. If you put charges on it.
Yeah, I have no clue.
Well, I said strong base. You have a table. It has strong bases at the bottom.
Where? This?
Yeah. I mean, only has two of them. You're going to need like 5 or 6. I'm playing music.
There's nothing. There's nothing. He said both of them. Water is not a strong.
Water's not a strong base. Look at the other side of the table.
LIO.
Look.
Side?
If we look,
What are you talking about?
first of all, if your table, you look at this. Where are the bases? On the left or the right?
Right.
Right. So what are the bases on this side?
Hydrogen
NH2.
peroxide.
NH2.
Hydrogen.
So there's one.
That's it. Oh.
Someone's saying hydrogen peroxide. I don't know what
OH.
planet you're
Is
on.
that an acid or a base? OH.
What are the things on this side?
OH. What?
What are these things?
Bases.
Base.
These are bases.
But, okay.
Okay.
PO4. PO4.
OH. OH is strong.
Oh, there is no OH here.
Oh, no.
OH is not a strong base. It's a product of a strong base. You're yelling out this.
Well, no, it's on the other side over there too. It can also be base.
Okay, OH. If I no
NaOH.
Say false base.
louder,
NaOH.
tell him.
Tell me.
NaOH.
So you're well, it's
No,
on
you have to say it.
So NaOH. It's on the, but OH is on the other side there.
Right, because that's what it makes.
What? What I'm saying, look up from the, or like O, oxygen. Look up from that is OH. Like that.
Sorry. Let me fix the table first.
Why did you erase it?
Hmm.
Why did you erase it? Marcus, that's one.
Because it's just confusing you right now, and I don't want to talk about it.
It is because you said everything on the right is base.
Everything on the right is a base of some kind.
It's possible.
These are the only 2 strong bases that are listed, but there's many other ones like
NaOH.
NaOH.
That's
Because we don't list all the solubility ones on here. So when I ask you for, what the heck? Did I skip this? No, I didn't. So when I ask you for a strong base, you can just say something that gives off hydroxide and is 100% soluble. Those qualify as bases. So that's a strong base. You can't say hydroxide because you can't go anywhere and get hydroxide. You have to get it with something. It needs a partner.
You can say like anything.
Yeah, pretty much.
Soluble to OH.
Yeah.
Okay. That makes sense.
Okay, now you have to give me a weak acid because I already got the base clean.
Weak acid,
Yeah, weak
like-
acid. Yeah.
Like boric acid,
Give me the formula.
H3BO3.
BO3?
B, yeah, H3,
Okay.
BO3.
Okay, good, that's fine. Isabel?
Strong
Weak base.
Weak base. H2O.
Yep, qualifies. Strong acid.
Strong acid?
Yep.
HBr.
Strong base.
OH.
With, because not by itself. Yeah. Mg's plus 2, so it'd be MgOH2. You're at weak acids.
HCO3.
HCO3. Again, charge minus 2, so you're going to need a 2 in there. Or a minus sign there, and then either one of those would work, but you got to pick one. Nicholas, weak base. HC2, is there a charge with that? Minus. Excellent, because without the minus sign, that looks a lot like just an acid. You're back up to strong acids.
HI.
HI. Strong base.
I'll get it. Oh,
Yeah, but remember the hydrogen goes
Right, with,
to what do you spell it?
There's a pattern with what's on the board.
yeah, no, I see the pattern.
Mhm.
Can I go, potassium hydroxide?
Excellent. The other white meat.
HCN.
HCN?
HSO3.
Is there a charge with that?
Yeah, negative.
Yeah, there we go. And then we're back up to strong acids.
H2SO4.
H2SO4.
Is ClO2 2 minus?
Sorry?
ClO2 and the charge is 2.
Hypochlorite. Yeah, it's not a strong base. Where is it on your table? Because this might be a good time for a discussion of what makes a strong base. What number is beside it?
Okay. Can't find it.
You didn't mean, you said ClO3?
I can't find it anymore.
Yeah, I don't think it's on the table. I think you said something else. However, they do say things, this is one of what I was going to mention when I said strong base, is they have strength of base here on this side. And then they have what's going to be KBs and KAs, what we're going to talk about. And then it gets stronger. So these bases are stronger, but anything above this line is still classified as a weak base. So PO4 minus 3 is still a weak base. It's just a really strong weak base because of how English works. But you don't get into strong bases till here, or any metal hydroxide. Because for solubility reasons, they dissolve, and so you're fine. And they're considered strong. So using that rule, what would you say for strong base? Yeah. O2 minus, yeah. Hold it, is it O minus 2 or O2 minus? O minus 2. Okay, Mia. Weak acid.
Wait, what do we have so far? HCO2. No, yeah.
Excellent. Weak base.
Would IO3 minus?
Oh, I think you picked the one you can't. Perfect. Oh, can you? Oh, I lied. I was thinking that one. But yeah, nope, that works. Darn it. IL3 minus. Oh, you're at strong acid again?
HCl04. Yeah.
H.
CL04.
Oh, yeah, that one works. Strong base. NH2 minus. So these are the only two on table. These, you just know. Any metal hydroxide, you should just know is a, and the table just assumes you would know. Because it's a solubility thing, not an acid-base thing, even though we're in acids or bases. It'd probably be helpful if they listed them, but they don't. Question? Notice as well, from last day, what would we classify these things as?
Oh, what do you call it? It starts with an A.
Mm-hmm. Right with my left hand.
Ambidextrous.
That's ambidextrous, and these are
Amphilate or whatever.
amphiprotic. The entire definition for Bronson-Lyer acids and bases has to do with proticity, giving up or accepting a proton. These are amphiprotic. I don't know if it helps you, but I used to always get it confused with ambi because of ambidextrous. But this relates to water. And where do you get water in? Amphorems, like those things the Greek had that like carry water. Ms. Hanley was studying Roman history at the time. It worked for me. Other than that, it's just a different word. Okay. Conjugates. I would like you to write the conjugates of all strong acids in here. And I don't think we can do all strong bases, but we can get close. Now, just as a reminder, if I have H2CO3, and this isn't, what is this, an acid or a base? Acid. What is its conjugate base? That's two things. HCO3 minus. What time is it? I have to keep an eye. I have to go soon. So, I want you to look, we just did the strong acids, you now know where they are. What are all their conjugates? You now know the strong bases. Come up with some rules for all the conjugates of strong bases, because they have special properties unlike the conjugates of all the other ones.
Are you going around or do you want us to say?
Write them down between you and your partner. I will just ask someone for them.
Strong acids don't have conjugates.
Yeah, they do.
Wait.
Yeah,
But
they
it doesn't
do.
have, it doesn't have equilibrium.
But it doesn't have equilibrium. So what are other
But it's
conjugates?
still conjugate.
But it's still conjugate. It's conjugate in a technical sense. Now, where's Karis?
She's at hockey.
She's in hockey?
Yes. She has been.
I know that. I know.
She took the test after she came back from hockey.
Yeah, and she's spoken to me personally about it. I think I should have done that. Okay, let's see what random 9. Preston,
Absolutely
pick you randomly. Give me as many as you can of the conjugates of the strong acids.
Cl over minus, I minus, Br minus, Cl minus, NO3 minus, HS.
Hold it, what after Cl?
NO3 minus, HSO4 minus.
Excellent. Conjugates, coal, of the strong bases.
OH minus. NH3. That's all I know.
Hmm.
If those are
So, yeah, because you can't do the same thing that you can with there. However,
Isn't H2O the conjugate of a strong base?
no.
Or H3O?
No. It's a product of a strong acid, but it's not its conjugate,
Okay.
if that helps. If we have things like NaOH and KOH,
Oh.
what would be the conjugates of those? Na, not it, well, because the OH would leave. What are you left with? Yeah, Na plus. And this is especially for the things that are soluble with everything, like Na plus, Li plus, K plus. What are these things? From solubility, they're at the top of the table. They're soluble with everything. Alkali ions. So one of the ones we can disappear, all alkali ions. Because if you have NaOH, the conjugate of that is going to be Na plus. You can't make sodium hydroxide in an aqueous solution and force it backwards. Its solubility is a one-way arrow. It doesn't get saturated in that kind of way. And if it does, we ignore that in the acid-base section for reasons I won't go into because that would make this too complicated. So we have a few there, we have a few here. Now, conjugates of acids are normally, if you have an acid, its conjugate is what?
The base.
A base.
This is you. Oh. Go small.
What are you watching? Because Preston was watching it too. Maybe just quickly look at this. So if we have an acid, what is its conjugate?
CH3C.
No. Any acid. If you have an acid, its conjugate is a
Without its
Base.
base. Like, yeah, not a trick question. The thing I'm trying to emphasize is you have strong acids. These are called conjugate bases. Can they be bases? No. They are bases in name only. They are there simply to provide the strong acid with an ability to give them away, essentially. They are called conjugate bases because they are the conjugate, but they can never accept the proton. They're too weak. It's a very unhealthy relationship. So, what we can say is these never act as bases to affect pH. And what would these never act as? Stop swinging it.
acids.
Active bases.
Pardon?
Bases to affect pH.
Never act as acids. to affect, effect. The reason you can't swing that is I literally think I'm hallucinating slightly. So every time you do that, I think there's a cat.
What?
Yeah. Teacher was talking to me in the photocopy room, and I kept going because a little piece of paper would move. So these never act. Well, this makes sense. We've already defined that as the ultimate base. That can't be an acid. That would be weird. So none of these can act as acids. Does that make sense? Nicholas, it makes sense? Excellent. Good. Nodding. I like nodding. Knowing nods are good. So never proton acceptor. And we emphasize this at the beginning because we're going to start training you to use the proton donor and then recognize the conjugate base and realize that it's also basic and have it as a proton acceptor. And once you get used to that, it's really easy to just assume that this works the same way, and it doesn't for the strong ones. There's only 6.
Is that supposed to say never proton acceptor?
Yeah. Never proton acceptor. Never proton acceptor. I mean, half of people aren't here, and I really probably should go. That's probably enough definitions for one day. I am going to leave and pack up and go. You have the rest of the class for Hebden. There are extra Hebdens in the back if you didn't bring any. I don't know why I did that.
Can we go for junior lunch?
But you're not juniors.
But
But you're not here.
so
I got a BFA.
But we're not learning.
You have a quiz, and you're not caught up in Hebden. Nobody is caught.
What if you're done?
Nicholas's Hebden has been sitting in the classroom for like a month. Not to call anybody specific out or anything.
We're supposed to be the question. We're supposed to be the question 11 on this.
Yeah?
Question 11 I did last night.
I will have a chat. I don't want to make things harder for anyone. So I'll see. But
This is Marcus.
continue on in the acid base. Marcus hasn't done his Hebden for at least a month.
No.
Wait, do you have my headphones?
What?
I don't have my iPad. Is that okay?
Yeah, do you upload it? Upload it to the thing. Because otherwise I don't know. And my assumption, if I don't know, is that you don't. Because lots of people don't. If you are in a hole where you haven't been keeping up, you need to catch up. The acid section will need lots of equilibrium. And I'm going to want to just take a look. It's not for you to develop good habits, but you can't understand it without knowing things and being able to reason with it, which just takes a lot of practice. Can I get this off the board? I'm going to shut her down.